this. You guys have watched me do a couple things using the bench mill, okay, and it's CNC.
Yeah.
So we got this up here, and I use those terms and stuff, and sometimes I forget. I should probably go back and really see if you understand what those words mean. So do you know what CNC means?
Computer.
Could be computer, okay? So the wonderful world that you guys grew up in, okay, I just Googled it real quick just to show you up on the screen here. So CNC means computer numerical control. This means a computer converts the design product by computer drafted software, CAD, into numbers. The numbers can be considered to be the coordinates of a graph, and they control the movement of the cutter. So there's CNC mills, and then there's CNC lathes. And I think when we talk about intro class, we talk about woodworking lathes, we're going to spin something and then use a cutter to cut that way. So it's a little bit easier to understand, but you know how I do things, and we jump right to the mill first. It's a little tougher to understand, okay? Because the cutter's more like a drill press. So there's an XY coordinate, and then there's also a Z coordinate. So when we talk about this, to make it work, you have to know G code and M code. So we talk about G code and M code. Okay, CNC milling, certain type CNC machines, down below where it says what is G code and M code. So to make the machine work, okay, G code deals with geometry of the hardware, for example, straight cutting developments, penetrating tasks, and determining the units of estimation. So what we talk about units of estimation, why does it say units? Okay, numbers, but what kind of units have we used in my intro class before? When we build the clock and things like that, what did we use? Huh? Inches, okay? And then when we did the CO2 car, what did we do? Centimeters, millimeters, which is metric. So there's two different ways that this machine will read that, but you have to tell it. Is your graph in inches or is your graph in metric? Okay, so that's one of the G codes. Then the M code deals with the configuration of the machine tools such as on-off, turning the spindle on-off, changing the tool, kind of going through things that way. This is going to be a lot for you. This was a lot for me. I haven't done this since I was probably sophomore, junior in the university when we first came out with these CNC machines. I know I'm not that old, okay, but they were just kind of new when I was getting started. We didn't have this conversion software that would take the CAD drawing and convert all this GM code. We had to kind of write it out ourselves. So it was just kind of getting new. So of course, in one of my classes, a manufacturing design class that I had to take, we had to do this. So I haven't had to do this for a while. So just like here, okay, I had to pull a lot of the Google stuff off. So what we're going to go through and kind of maybe talk to you a little bit about how this works. So here's a G code, M code that I wrote. So the first thing is turn to that last page. And what do you see on that last page? Okay, it's a graph. So kind of turn it on its side a little bit. And on that graph is basically the plane that the mill's going to use. Okay, so I had to first design, got to have an understanding of how I was going to do this. So on that graph, just like you had to use a graph paper when we did your clock, you know, we had to scale out how to draw your profile for your clock part. On the side, these little squares, okay, what did I make each little square? An eighth, okay? So we do an eighth is you break this down across this, how wide does this block get? 5. How tall?
3
3 3/8. Well, it goes to 3.5, but the last line is what, Claire? 3 3/8. Okay? So I did this. I don't have enough for everybody because you're going to eventually get into groups. look at that, of course, it's not the life size of this graph, okay? And I did that just when I plotted out on the graph, so I can kind of see the points a little bit better when I'm kind of writing the code out. So when you look at those, I wrote all the little commands there. As you see the points on the graph. Okay, so I'm going to pull that up now. So I kind of came up with, I was kind of like, how am I going to do this for students so we can kind of be organized and understand this? So when you put it in the computer, okay, you have to put it in line by line by line by line. So start with that first one. So I just kind of did this template here that you will eventually fill out for a project. So as we go through this, what's that first step? What am I telling it? Okay, what is it? G what? 20. So my little summary there, what am I telling it? Coordinates is in inches, okay? So this G code, I don't have them all. As you can see, there's 1, 2, 3, 4. Okay, I didn't put 5, 6 because some of those are ones that we're just not going to use yet. And then 9, 20, 21. Okay, so those are kind of what it's telling it is it's inches. You could do metric if you wanted. Then of course I put the M code over here telling. So these are just the same for any CNC machine. Okay, this G code and these M codes are the same for any machine that you put in. Anywhere. Okay? So then the second line, what am I telling it? Tool change to 1, okay? T is tool number 1. So if you look in the machine here, and you guys have looked in here a few times, there's 4 tools. Okay, so there's 1, 2, 3, and 4. So these 4 tools have all been set up in here that when you tell this machine to go grab it, it picks it up, comes over and does whatever you tell it to do. That's sometimes something you have to do depending on what kind of material. So there we're using just a standard 1x4, but if we were using a 2x4, we have to reset the height. It's not that hard, it's just something you have to do. Now, if you want to avoid having to reset that all the time, there's a lot of manufacturing production places will set up jigs. So you have a jig attached to the clamp here, and then you just put a new product in, and every time the product's in the same spot, and then the machine just goes by itself. You have to reset it all the time. Okay. So what am I doing at number 3? Rapid movement. Okay. That's important to understand that G00 and G01. G00 is rapid movement, so it's going to move a little faster. And then G01 is a slow movement. Why do you think they have those two different? Could be thickness, okay, but that has more to do with F, which is called the feed rate, which is how fast the machine is going to move when it's cutting. The rapid movement increases production when you, for instance, lift the tool up and then move to a new spot. So then you're not all going the same spot. So it's kind of slow then if you use just G01. Okay, and it took me a while doing a couple programs on here to figure out I need to speed this up somehow. Well, then you have to enter G00 in and then go to the coordinates. Then number 4, what are we doing? Turn the spindle on which way? Clockwise. So you have to understand sometimes with the tools, you're going to go clockwise and sometimes you're going to go counterclockwise. Okay? So we turn the spindle on and then what? What's S? Spindle speed. So you can change that spindle speed, okay, down based on, just like the router when you were in the wood shop, the bigger the router bit, okay, a little bit slower RPMs you want to use. Smaller the bit, higher RPMs you want to use. I think this goes up to 5,000 RPMs. I haven't turned it on that far, but then when you change bits or you use the edge finder to set your X and Y coordinates, okay, you actually have to slow it down to 500. You don't want to spin at 3,000 RPM when you're trying to set that. So there's different things you have to use for this machine. So we got the spindle, and then what's F6? Feed rate, okay? I haven't really found a chart yet that kind of tells you the feed rate and like what it all means, other than me using this. So why would I want a different feed rate between using pine and using oak? Oak's harder, okay? So oak's harder, so it takes a little bit more to cut it. If I use a faster feed rate, what could happen? Break the bit. Okay, the bit could break off. So that you gotta kinda have that in your mind too, when you're setting this, decide what kind of material you cut into. If we get a chance to get some more wax or plastics, okay, then we can even speed the feed rate up faster, because these are a lot softer. So you can cut them a lot smoother and a lot faster, a lot quicker through the process, okay? But all you have to do is just go back and change your feed rate. You can change your feed rate at any moment through this, okay? So then number 5, what am I telling? Where to put the bit, okay? And where is that on the graph? Okay, so when we're looking at these X, Y coordinates, where's X at? Okay, how do you know that? Yeah, well, what class did you take? Jump, holy cow, math class? X-axis is the one across the bottom, okay? Then up and down is what? I'm gonna tell Miss Peters they knew what they were talking about, right, Mrs. Litter? Okay, that's good, okay, good job. So what's the Z coordinate? Yep, that's the one that's over top that's gonna tell it to go the depth, up and down that way. So when I set this, I wrote it out here, what each step is, okay? So 4, I just kinda told it to go to that spot. Or excuse me, it's step 5, so we're at X 3/8, Y 1 and 7/8. That's the other thing that's gonna be kind of tricky, is you can't put fractions in, okay? So on this part, and I think it's also on your paper, I put all those conversions on there. Okay, what is the decimal point of a 16th, decimal point of an 8th? A lot of that just comes to memory for me because I had to learn all that in college, and I still use it now when I'm using CAD. When I'm using AutoCAD to draw 2D stuff, use decimal points a lot when you're putting in measurements and such. It's gonna be the same thing here, but I just kind of put it there so you can kind of refer back to it. So we go to that X 3/8, so you guys understand that you go left to right, and then we go up an inch and 7/8 according to this graph, okay, and then step 6, what am I doing? What's the first code? Okay, G01, so I'm going, remember, I was in G00, which was rapid movement. So now I'm G01, so I'm telling the machine, hey, we're gonna slow down, and then we're gonna do what with the Z? We're gonna go down. Now this decimal I did not put in there. I just didn't have that set over because I didn't like the depth. I thought an 1/8 was too much when I was cutting it, and I thought a 16th was not enough. So I put in 0.09375, which is actually 3/32. Okay, so how did I get that decimal? When you have a fraction. You have a calculator and you know it's 3/32. How do you find the decimal? 3 divided by 32, and it gives you 0.09375. Now, why did I have to put a negative? So it goes down, okay? Because when I set the machine up, I set everything up so the top corner of your board, excuse me, the bottom left corner of your board is X0, Y0, Z0, right on top. So then anything negative you put down is going to put that cutter down in there. So at step 6, it goes down. Now step 7, I put on your graph, okay? Excuse me, actually step 5 is there, and then step 6 we go in, so then step 7 means what? We start cutting, so we're going up the y-axis, okay? The x-axis stayed the same between 5 and 7, okay? Stayed at 3/8, 3/8, we only changed the y, so we went straight line up. Okay, and then step 8, we went where? Went to the right, okay? How far did we go to the right? Quarter inch, how do you know quarter inch? Each square's an 1/8, and I went how many squares? 2. Okay, so that's the other reason we kind of take these squares and we make them a measurement. You could make this, you can make each one of these a quarter if you want. Okay, whatever kind of works out. 1/8 works out the best for the size of material and kind of projects we're doing. So Step 8, we come over. Now, this is where it gets tricky and it took me a little bit. Step 9. It's having you cut a what? Is that a straight line? No.
Clockwise.
Okay, it's an arc. So the thing about the arc is you put G02. And what is G02 telling it? Clockwise. So when you look up, you gotta think about a clock. So it's going clockwise. Okay, now, so G03 would be what? Counter, you're gonna be going the other way. Okay, so I'm telling it from the position of 8, we're going clockwise arc of a radius of what? Quarter of an inch. And then we're going to step 9 is our ending point in step 9. Okay, so where it says X 7/8, Y 2 5/8, that's where we're ending on that arc. So then step 10, we're doing what? We're finishing that arc, which ends up being a half circle. That's where I had a tough time trying to learn how to do arcs on this, because we thought we could just do that whole arc. But it wouldn't let us in this G02 code. Okay? So that's why I had to do this in kind of 2 steps, and that's happening on the graph paper. So then how did I know that the arc was a radius of a quarter? Which would be a quarter. Yep, good. Okay, so Christian, everybody kind of understand that? So if you look at the end point of where that step 9 is on your graph, okay, you kind of draw those lines over where they meet. Okay, they're down a quarter and it's over a quarter. So that would tell you that the arc has to be a quarter. So your radius could change depending on where that second point is. You could have an 1/8 inch radius, you could have an inch radius, depending on where that second point is. But this machine, if you put G02 and you just put the X, Y, you leave out the R, when it gets to that step on the computer, it's just gonna stop. It's gonna tell you incomplete location. So that's kind of nice. But then you have to go back and figure where did I mess up, what I forget. Okay? So as you go through this, I have all those listed there. So you can kind of see where all those went. So then after 13, let's scroll this up a little bit. So at 13, I finished what letter? The point
R.
The R. I finished the R, okay? So then what do I want to do with Z? So in step 14, what did I do? Up. And I did rapid movement, and I moved the Z up just a quarter. So that means it's a quarter above the workpiece. And when we first started doing this, we were just putting 1. That was taking a long time too, because it was going up all the way to 1. Why does it need to go up to 1? It doesn't. You just want it out of the material to make it, you just want to get to where you can cut as fast, you know. You want it to look nice, but you want your production to be as quick as possible. So then at step 14, okay, we raise it up. So then step 15, what did I tell it? Yep, 1/4 inch. And then step 16, I did what? Phasing, that's G01. Slow movement. So I went back to slow movement and told it to put the bit in that same depth again. And then 17, this is where I kind of think about my coordinates, because now I have to go up at an angle. So my X and my Y both change, right? And then the other side of the A, I just went right back down to that. So step 19, I had to do what again? Albert, what did I do at 19?
Oh, you did the rapid movement.
Rapid movement, what is Z?
That's your part. Oh,
So where did I go?
you went up.
Went out of the material, okay? So then 20, I went to that cross member of the A, right? So when you're going through this and writing this, you gotta think about what's the easiest way to get these letters to go. And I don't wanna give the impression that when you're doing a mill or doing a lathe, it's not just to make signs and logos, stuff like that. But this is a way that I think that you can learn it the quickest and easiest and get an idea of what a machinist does. When you go to actual production and you're gonna make actual parts for like ag equipment, cars, trucks, other machines, do the drill holes for the mounting parts of it, or a place for the bearing to fit into. Okay, so then you get a little bit more specific about tolerances and cutting and offsets. Okay, because that's the other thing with this, we're using the engraving tool, so the tool comes down to a point. So when we're doing that, wherever we put here, that, so on 15, that X 1 1/8 and Y 1 7/8, that point of that bit's going there. Now if I was using a cutter that was a 1/4 inch wide, the center of that 1/4 inch is what goes there, not the edge. So now you can get even more kind of specific about how you have to do your offset of that point. You gotta think that bit's a 1/4 inch, so I'm going 1/8 inch on each side of that point. Or if I'm doing a 3/8 bit. Okay, now I'm doing 3/16 on each side of that bit. So there's a lot of things that I can't teach you in one class period, probably even 1 week with this machine. But to do something like this, I think you guys can do. Okay, so any questions? So the G code and M code. So what we're gonna do, okay, is I'm gonna give you another sheet here. Do you want me to set the groups of 2, or do you want to do them yourself? Do it yourselves? Okay. Who's with me? Who's going with? Who's Ice Cube? You're going with Ice Cube? Who are you with? Good. Okay, so now you got your own sheet. So what you're going to do is, so the one that I showed you says what?
Raider Industrial.
Good job, Raider Industrial Technology Department. I want you to do something to either be ESC FFA, ESC basketball, ESC football, or Raider FFA, Raider golf, Raider, I don't care, something like that. So the big thing, what's the first thing you have to do?
Figure out where.
Okay, you're gonna draw on this page, you're gonna draw it out. Okay, draw it out here, and then this where you can start writing your code on there. Now, once we get to that spot, which I'm hoping by tomorrow or Friday, and then on the computers, okay, we have the exact same software that we have here, and you can start entering that code in, and then you can have it go, and it will actually simulate the top corner, just like here, the top corner of your software. So it did it on the machine, for this top corner, it'll cut it out on the block too. So then you can try and practice before we even get on this machine and do it. So then you can catch out any mistakes that you might have and then figure out where are my mistakes at. Okay, questions? Are you excited?
Yeah.
Good, give it a try, all right? If you have any questions, make sure you ask.
No, no.
All right.